Rates of change. Example 35. A cube is expanding in such a way that its sides are changing at a rate of 4 centimeters per second. Find the rate at which find the rate of change of the total surface area of the cube when its volume is 216 centimeters cubed. Alright, so let's try and get an appreciation of what's happening here. So there's a cube, and the cube is of sides L by L by L. So we're told that the cube is expanding in such a way that the rate of change of its length with time, dl by dt, is equal to 4 centimeters per second. So this is saying that every centimeter, the length is changing by 4 centimeters. Sorry, every second, the length of the cube is changing. Either it's getting bigger or it's getting smaller by 4 centimeters. Let's just assume that it's getting bigger. So every second, the length increases by 4 centimeters. The fact that it's positive, I'm going to take that to mean that it's getting bigger. Alright, so what we have is dl by dt, and what we're being asked to find is we're asked to find the rate of change of the total surface area. So in a sense, what we're being asked to find is dA by dt. Now dA by dt would be equal to dl by dt, that's what we have, multiplied by dA by dl. Alright, so like I said, for example here, the dl's will cancel and you'll be left with dA by dt. So we have dl by dt, that's what we have, that's what we started, that's why we start with it. Now what we need to find is dA by dl. So to find dA by dl, I need to have A, the total surface area, in terms of L. Now the total surface area of a cube, A, is equal to 6 times L times L. Now the cube has what? 6 surfaces, and all 6 surfaces are identical. The cube has 6 surfaces and all 6 surfaces are identical. Therefore, A is equal to 6L squared. So let's differentiate A with respect to L. Therefore, dA by dL is equal to 12L. So it means therefore that dA by dt is equal to 4 multiplied by 12L. So dA by dt is equal to 4 times 12 is 48L. Alright, now what we need to do is to find dL by dt, sorry, dA by dt when the volume is equal to 216 centimeters cubed. Alright, so let's go back up top here. Now the volume of a cube, volume, is equal to A times H, which is equal to length times length times length, which is what? L cubed. Now when V is equal to 216, L cube is equal to 216. The opposite of cube is cube root. So therefore L is equal to cube root of 216. L is equal to 6 centimeters. So when the volume is 216 centimeters cubed, L is equal to 6 centimeters. Now, when L is equal to 6 centimeters, dA by dt, which is equal to 48L, would be equal to 48 times 6. Alright, 48 times 6, which is equal to 288 centimeters square per second. So when the volume of the cube is 216 centimeters cube, the total surface area is increasing at a rate of 288 centimeters square per second. Next example. Example 36. It says two variables x and y are connected by the equation y is equal to 4x into x plus 2. If x is increasing at a rate of 2 units per second, so here dx by dt is equal to 2 units per second. Alright, find the rate of change of y at the instance when x is equal to 6 units. Alright, first of all, y would be equal to 4x squared plus 8x. So I have y in terms of x, so I can find dy by dx. dy by dx would be equal to 8x plus 8. And we're asked to find dy by dt when x is 6. Now, dy by dt would be equal to dy by dx, which we have, multiplied by dx by dt. Alright, it's sort of like the dx's would cancel, leaving dy and dt. Alright, so we have dy by dx, which is what? 8x plus 8, multiplied by dx by dt, which is 2. So next I can say now when x is equal to 6, dy by dt would be equal to 8 times 6 plus 8 multiplied by 2. So this is 48 plus 8 multiplied by 2. So this would be 56 times 2. And I'm guessing that this would be 112 units per second. So when if x is increasing at a rate of 2 units per second, dy by dt, I have dy by dx, not dy by dx, it should be dy by dt. dy by dt, or y, is increasing at a rate of 112 units per second. Next question. Example 37. It says a spherical ball is being inflated at a rate of 40 centimeters cube per second. So here's what we know. I know that dv by dt is equal to 40 centimeters cube per second. All right. V here, in dv by dt, the V stands for volume. How do I know that it's volume? Because the unit is centimeters cube. So the unit of length would be centimeters, the unit of area would be centimeters square, and the unit of volume is centimeters cube. So if the ball is being inflated at a rate of 40 centimeters cube per second, it means therefore that the volume is increasing at a rate of 40 centimeters cube per second. So that is what we have. We're asked to find the rate of increase of its radius. So in a sense, we're being asked to find dr by dt. So dr by dt would be equal to, we have dv by dt. Now we need to multiply this by dr by dv. dr by dv. So here again, the dv's, it's almost like the equivalent of the dv's dv by dv being cancelled, but that's not actually what happens. All right, so we need volume in terms of r. Now the volume of a sphere, volume is, I think it's equal to 4 over 3 pi r cube. I hope that's correct. The volume of a cube, of a sphere, is 4 over 3 pi r cube. Now, so we really, what we have is what we have volume in terms of r. So therefore, dv by dr would be equal to 3 times 4 over 3 pi r, decrease the power by 1. So it's equal to what? This is 4 pi r squared. So dr by dt would be equal to dv by dt, which is 40, multiplied by dr by dv, which is the reciprocal of dv by dr. So this is 1 over 4 pi r squared. 4 into this is 1, 4 into this is 10. So dr by dt would be equal to 10 over pi r squared. All right. Now we need to find dr by dt when we're being asked to find dr by dt. We're asked to find dr by dt given that the surface area, find the rate of increase of its radius, given that the surface area is 200 pi r squared. Now, the area of a sphere, A, is equal to 4 pi r squared, and this is equal to 200 pi centimeters squared. So therefore, r squared would be equal to 200 pi divided by 4 pi. The pi's cancel. So this is equal to r squared is equal to 50. So r would be the square root of 50, which would be the root of 25 times 2, which would be equal to 5 root 2. So r is 5 root 2. Now, what we're being asked to find is, we're being asked to find the radius the rate of increase of the radius, given that the surface area is 200 pi centimeters, 200 pi centimeters square. So if the area is 200 pi centimeters square, the radius is 5 root 2. Now, when r is equal to 5 root 2, dr by dt is equal to 10 over pi times r square. I think r square was 50. From here, r square is 50. So this is equal to 10 over 50 pi. Therefore, dr by dt is equal to 1 over 5 pi. And this is centimeters per second. So when the surface area is 200 pi centimeters square, the rate of increase of its radius is 1 over 5 pi centimeters per second.